Good morning, everyone. Welcome to this first video. This is first video on my channel. It's only a bit of fun as I mess around on C# and produce certain programs with certain outputs. There's no particular aim or goal to all of this. It's a bit of a peruse. It's a personal playground where I go through whatever's on my mind, pretty much. Happy to take suggestions, which is what the comment section is for. Um, for now, this is the first video, the inaugural video for this channel. So I start off with something interesting, let's say. This video will be on the subject of prime numbers. So a prime number is any number that is only divisible by itself and 1, or -1, negative itself, I suppose. Strictly we'll be dealing in positives. But what we aim to do today is create a simple script, build it up from the bottom. So can we produce a script that produces integers only, let's say, from a certain range? And then can we define prime numbers within the range? And if we have a bit of time after, then we can see if we can extract the divisors of each number along the way. So I'll explain the steps as I go along. Hopefully this is informative for you. Hopefully you find this interesting. Yeah, let me know. Hope you enjoy it. Yeah, let's get into it. I'm on Programmers. This is the online C# version here. This is a new laptop and trying to figure my way around here. So for now, I'm going to use this online version until I get set up on the C# proper. I believe I need Visual Studio, Visual Software, Visual Studio, VS, to get this up and running. I don't have that yet, which is why I'm here. I'm hoping the functions are all still the same, and then I can run this seamlessly without problem. Let's see. So let's go. Prime numbers. Let's produce something. Let's produce this. So start off. Can we produce a simple script that can produce integers, a certain list of integers from a certain start point and end point? So let's do that. Let's clear the board. Start again. So I need system package, separate by break, and let's run this program. Class and program. Then don't need a link there. I need a loop. So there's my first loop, static and void. So I believe static void main. Main indicating I believe this will be my first loop, and it's going to set the tone for everything as we go along. Static. Static is a standalone, I believe, a standalone function. Doesn't really need anything to define it. The void is let's say a simple output. It's not necessarily asking the program to find anything, to add anything, to divide anything, to check anything. What I need the static or the void here for is to merely output something. And what is that something? That is going to be the integers. So to define the int as integers, start, and I'm going to define, let's say, I don't know, let's make this a bit exciting. 100 to start from 100. That, and where do I want this to end? I want this to end, let's say, I don't know, 200. Let's say 200 for now. So how do I actually define this? If I started like that, I think it'll output everything. So let's run that. Nope, nothing. Okay, so it's not going to put out everything. I need to define the actual range, or what do I want to output still? Or maybe that loop's simply not defined. So int n, where do I want it? I want to cycle from the start value all the way till the end value, so inclusive of the end, u and u, so the greater than less than end, and plus plus. Okay, and I believe I'm going to need to write this line at some point here. That would be helpful. Where do I want that? Loop across, yes. Yeah, okay, good. So I'm going to need u again. Static and the void, yes, I'm going to shift that over there to u. I want the console. So this is where the console output, so this on the right here will start to output. So I'm pressing control here on my computer, and this is the first time I'm realizing that I can't. Ordinarily, when I press the control, the mouse is supposed to circle around to indicate where the cursor is, so it's not doing that for me today. Don't know why. Maybe it's this new screen recorder tool I'm using. So what do I get when I do that? Great, so I've got 100, 101, etc., all the way down to 200. So not a very expansive list, but if I start to do something a bit exciting, 100 to 20,000, what does that give me? Problem still? No? Okay, all right, I'm going to trust it's gone all the way to 20,000 for now. So, very good. And that's the first part, right? We've outputted the integers. Very good, I'm happy with that. Let's move on. Okay, so what do we want to do? Let's define the primes. So we've got an output here, which is the integers that we care about, but can we make the script identify what is an actual prime number or not? So for this, we're going to need to, let's expand this. We need to do two things. We need to tell, or at least find some means to have the program define what a prime number is, or recognize what a prime number is even. Then we need to link that definition of the prime back into our original loop in the static void here, so that it can, again, link up with the prime numbers and output what is a prime or not. So recognizing and outputting. How are we going to do that? So I believe we need the static bool and the is prime function. The is prime function, spell it correctly, please. Going back to the original integers which we defined earlier, number, yeah. So static bool is again used in this case to define the loop. Maybe that's not the best description. And again, I'll come back to that. The bool function is a simple yes or no. Is the integer prime? Yes or no, or true or false in this case, and we need to build that out. So how do we do that? So let's start off with a few prime definitions. So if the number is, if the number is less than or equal to 1, then by definition this is, what is that? That's not prime? Yeah, that's not prime. Not prime. Oh no, what am I doing? Return is false because it's not prime. Okay. Then we're going to do the same with 2. Okay, return true. If number, and so this, what I'm doing, the percentage 2 equals 0. This is where it says for any integer greater than 2 that is even, is it a prime number? No, it's not. So that will be not prime, and we're indicating that with a false. Okay, so we need to run this a bit further. So we need to run those 3 commands here from 19, 20, and 21 over the integer list up here that we defined earlier. So how do we do that? So we're going to run it from integer limit. How do we do this? I'll explain this in a minute. Let me just write it out. Integer math square root number. Okay, why am I doing this? So we're going to define a limit. This first part here is defining we want an integer that will be set as the limit. And what is the limit? It'll be the square root of whatever number it is in question, i.e. we're going to go back to the integers up here. Let's say we want to find the prime numbers, or if, let's say 150 is a prime, let's set a limit. That's probably not the best number. Is there a square root between that? 121? Yeah, let's say 121. We're going to find a limit for the square root of 121, which is 11. And what we're going to do is we want to find all the numbers between 1 to 11 that divide 121. The idea being is that there will be pairs of numbers around 121, or 100, the square root, which is 11. That will be a pair. Or maybe a better way to describe this is, for example, 10,000. 10,000, the square root is 100. So the divisors will be 2 times 25,000, 4 times, no, what is it? 2 times 2 times 5,000, 4 times 2,500, 5 times 2,000. But all of those pairs that I'm saying, they're going to be centered around 100. So you're not going to have any pair that's going to be like 5 times something less than 100. Or divisors are not going to be something less than 100. So that's kind of the logic we're aiming for here. So I'm going to let's build that out. Let me just continue for integer int. Again, starting from greater than 3, I less than whatever this limit is. Oopsie. Oops. Limit int I, again, cycling to 2. So what's going on here? I need to move you down. If I need to move you across, if number percentage from the 1, I equals 0. So that's sort of defining if it's an even or odd in and of itself with the I. Return false, okay? Otherwise, it's true. So let's say this again. So again, it's searching for all of the numbers up into the square root of whatever that number is. It's going to recognize what those pairs are. So it'll cycle through any of these numbers up until that limit. Anything beyond the limit, you're sort of doubling the work. Okay, so that's that part, and I think I need to close that off with a semicolon. I need some more semicolons. I'm missing a load of semicolons out here. No, I'm not. Okay, wait, no, I'm good. Okay, so that's the prime number part. Have we recognized the prime numbers yet? Is that going to work? Okay, that's fine. It's still going to output it, but we need a way to connect this loop down here with this console output. So it's all well and good that we've outputted all the numbers, but we actually need to find some way to determine or link the prime numbers to the actual output. So let's do that. So I need an if function here. I need an if and an else. So what's my if? The if is going to connect to the is prime. Yep. And now what? I need the console to write a new line. Write line. Yeah, thank you. So this is sort of syntax writing here, I guess. It's again cycling through the lines of n, or cycling through n's, all the integers. Is it a prime? This will be the first one. Is it a prime number? Okay. Okay, so otherwise I need it to do the opposite. Console write. We need that out n is not a prime number. Okay. Close that. Close that. So does this actually run? Will this run for me? Perfect. Okay, so 2 parts. Recognize that it is a prime and output if it is a prime or not. And so that's what we've done with the second part. So that's quite kind of neat. We're going all the way from 100 to 200. That's pretty cool. I believe this is correct. Prime number, prime number. Let's try something different. Maybe you can build that out. Let's add something visually a bit more, make this a bit visually easier to look at. So I want to add a line between all the primes or not, so I can simply have a visual break here. That's not helpful at all. Visual line. Space. Yeah. No, okay, that doesn't matter. I want to write a line. How do I write a line? Do I need that? No, okay. What's the other way? There's another way you can do this, and that is with the n. What now? Great, okay. So 101 is a prime number. Yeah, that sounds about right. 102 is not a prime number. Divide by 3, I believe. 104 divided by 2. Yeah, sounds about correct. 105 divided by 5. Yeah, sounds about correct. I don't know if this isn't working right. I don't know on site. I don't know if anything is a prime number or not. If it's not, if it's a trivial ending in an even number, yes, that's fairly simple enough. But if I don't know 183, I wouldn't know if that's a prime number or not. Oh, okay. Well, that's what the next part is up to then. That's what we're going to do. That's what we're going to do this next part. So, can we actually give some credibility to this? Can we output the actual divisors to this? So, okay, now consider this part 3. Can we output the divisors? So again, we're going to need to do 2 things. Can we define what the divisors are? Can we recognize them? And then after that, can we link that to the original console output here, so we can actually produce the divisors? So how on earth does one do that? Let's define another loop then. So I'm going to go down. It's not going to let me go down here, I realize. So if yeah, okay, that's fine with me. Okay, so let's define something else. Static I enumerable int. And what this is doing, the enumerable, well, that's not going to do anything because that's not spelled correctly. I enumerable, it's simply a list. That's all it is. It's a list. So whenever you're defining some sort of output involving a load of numbers or even letters or some sort of output, the enumerable, I believe, is only a numerical list. Okay, so get divisors. So let's set this function, get divisors, int number. And so now we want to set the second loop, or the next loop, this loop, yep. Can I get another? Oh, it's not going to allow me to do that. Okay, so I'm missing a loop somewhere. I think that's you, yeah. You're not going to allow me to do that. I think it's you, yeah, okay, got it, there we go. So, what was I going to do? So, let's, the var set, and I've been trying to figure out what exactly is this var? What do we mean by var? It's not variance, variability. Variation. It's nothing to do with that. I couldn't quite find what this is. If anyone in the comments can help me out here, I'd be really, really grateful for that. Okay, so I'm setting a list starting at 1. Okay, and include these again, the integers up until this limit. So we're going to do that thing again that I said. We're going to introduce the square root as the top limit. Square root number. So again, all the divisors will appear in pairs around the square root of the number. So, oh, maybe that's something I should have done, the 10,000. So 10,000, oh, I'll go there in a minute, but the 10,000, square root is 100. All the pairs of divisors will exist around this pivot, which is the square root of 100. So remember, there will be no two pairs of numbers that will be multiplied together to equal 10,000 if they are both less than the square root. So consider that the max you'll get is 99 times 99, which if I get my maths correct, is equal to 9,801. I think that's correct, and I think it's definitely correct, so I just use the calculator. All right, so next, let's move on. I'm setting that limit again for integers I is equal to. I'm not sure how much of this is even programming. I'm sort of going through the theory of prime numbers anyway, but I'm hoping the coding or the script writing actually outputs or is actually communicated here. I equals plus. Let's do that again. I need some more of that limit there. If, so again, we're going to define the number if here, percentage. So again, the I is equaling 0 is going to sort of help define is it an even or an odd number. And at this point, I've kind of don't remember why that was important, at least not in the context of this loop. So set dot add I, and I'll explain this in a minute after I write it out. Colon set dot add number divided by the I. So what did I do here? So what this is again, going up to that square root limit here, it's going to define that loop, or at least cycle all the numbers up until that limit. And what it's going to output is whatever the first divisor is. For example, for 10,000, let's say the square root is 100, and the first pair would be, let's say, 2. So 2 divides 10,000. So that's the add I, and the set add number I will be the whatever the number that is, which will be 10,000 divided by 2. So that will be 5,000. So do I need something else here? I think we need to end the loop here simply by defining what is it we actually want to output. That's the set. Simply return the set. Okay. So we're not done here. If I run that, we're going to get nothing. Yep. Because we need to fix this here. How do we actually link the divisors here? So I think we actually need something else. We can't simply run the divisors. So there's a package we need, system.collezione, degeneric that, and that's still not going to do anything for us. Okay, it is. But we still don't have the divisors, and that's because we need the console output. Okay, so let's finish this off. So is prime the console? We need the divisors. So for the prime number, there are no divisors. There's nothing by definition, there are no divisors anyway, so we don't need to fix that. It's this line down here that we need to fix. So I'm going to keep that, the var as prime number. I think we can keep that. So again, this var divisors is going to retrieve the divisors which we highlighted earlier. Get the divisors somewhere. Well, that's not it. Okay, well, somewhere it is. So get the divisors equals the string. So we want all of those numbers to be outputted. Join output, whatever it is. No, I've already done that. Okay. Get divisors. Okay, so now we're linking it back to the divisors. N there. So I don't think that's going to run. We need to actually say what the divisor. Yeah. Oh, right. So the divisors are the string. We're defining the divisors here by saying what are they? They're just simply all the divisors. Simply retrieve all the divisors from this list below. So from the get divisors. Now what? So is not a prime. Then what? We can add them on here. Divisors. Divisors. Right. That will be the list of divisors. Yeah, okay, so let's run this again. I'm gonna make this smaller so you can see. Will that output? No. What have I done wrong? Var divisors equals string dot join. What is wrong? Okay, it was correct when we wrote it down. Yeah, it's not a prime. Oh yeah, I need to define a loop. Sorry, okay, that is a loop. Yeah, okay, so you and you, I think. Yeah, that is most certainly a loop. Okay, but why not? Yeah, because you still haven't outputted the loop. Maybe if I put the square bracket there. Yeah, okay, there we go. So now we've got all the divisors. And I hope here this could be a bit easy to visualize. So let's go into 10,000 actually. Let's show you what I was talking about earlier. I'm just going to close that script a bit to make this easier for the output to run. If I go to 10,000, great. Okay, so here, this is what I was talking about for 10,000. All of these pairs are going to exist around the square root of the number. So 10,000 square root is 100. They'll come in pairs. So forget the one, it'll be 2 times 5,000, 25,000 times 2,500, sorry, times 4, 5 times 1250, 1,000 times 5, etc. But they're all going to coalesce or center around this 100 value. So that's all well and good here, and I think I'll do one last thing. Give a visual effect even. So system threading. So let's add some threading. And what this will do is it'll print the line, sort of like a printer even. No, not like a printer. What do I want this? I need the thread if the sleep. Yeah, yeah, I need you here. So what do I want? Oops. Okay, doesn't matter. Thread dot sleep. And let's output every number at an interval of 1 second. And I think that'll output it. Nope. I need to close that. Sorry. No. What have I done this wrong? Threading? Have I spelled something correctly, maybe? Thread. Sleep. Capital. Surely. Is that a capital? Must be. Perfect. Okay. There you go. And that'll stop after 10 seconds after we get to 10,000. Great. Perfect. Happy with that. If you want to see that small scale, let's bring that back to 100 and let's run that to at least 10,000. I don't think it will 1,000. I don't think it will get to 1,000, but maybe it'll stop for that. Half a second, a fifth of a second. And yeah, okay. So what does that look like? One after, yeah, there we go. Okay, so that's it. That's all I wanted to show today. To recap, it's a script that outputs for any list of integers between a set start and a set end. In this case, 100 to 1,000. Can it determine if the number is a prime or not a prime, and can it determine what the divisors are? So the mathematics behind it is, I suppose, simple enough. The scripting is well, nuanced, let's say, caveats and certain things to look out for. But this is interesting. I enjoyed that. I hope you enjoyed it. I hope it helps in your endeavors, whatever that is, if it's a project or if it's scripting that you need some sort of line from this, let's say. Well, I hope this helps. Hope you enjoyed it. If you have any comments at all, leave them in the comment section. I'll read them and I will respond to them. It's a learning process for me as well. So any help you have, if I could do something simpler, maybe if there was a line that isn't necessary, if there are 5 lines or something that can be combined into one, let me know. Happy to learn and see if I can bring up your suggestion in a future video, whatever that video may be. I don't exactly have a script or anything. I don't exactly have a list of ideas for this, but as I say, it's sporadic. Whatever's on my mind at this point, whatever I can apply to a program, I will make it sort of on the fly, and I will make a video of it. So I hope you found this interesting, and hope to see you next time. Yeah, thank you for joining me. Hope you enjoyed it, and see you soon.